So, good evening, children. First of all, sorry for posting this video so late, but doesn't matter. All good things take time to come, so we need to understand this. Now, if I'm looking a bit unkempt, then please bear with my looks that I cannot change. So, anyhow, coming back to the concepts which we were discussing. And I remember I had told you about the object-oriented concepts, and we had stopped, and I had promised you that I'll be coming ahead with the new video on basic concepts of OOPS. Now, when we talk about OOPS, if you remember, I had told you that OOPS stands for Object-Oriented Programming. Now, just to remind you, what is Object-Oriented Programming? So earlier days, from your past experience, you might be knowing that to save any data in the system, we need to create variables. But there is a problem. The problem is that as many data we have to store, that many variables we need. So in my last video, I had told you that suppose take the case of your report card, you have got 118 data there to be stored in a year. So if one student has got 118 data, so imagine if our school strength is 2000, then 2000 into 1800 variables will be requiring. So that was the problem, and that is why we came to this concept known as object-oriented programming. Now, what is an object? Object is a packet created in the memory to store data. Now, this particular concept of creating packets to store more than one data together really revolutionized the complete concept of programming. And it was introduced with C++. And as far as I think and as far as I understand, this concept is going to be there for another 30-40 years. Okay. So that was the concept of object. And when we talk about objects, then we come across object-oriented programming concepts. So what are these concepts? So basically, when we talk about concepts, we mean to say that these kind of properties or these properties are inculcated in the program whenever we write a program using this technology or this technique. So the very basic or the very first concept of object-oriented programming is data abstraction, or we simply call it as abstraction. So what is abstraction? As the book defines, abstraction is the act of representing essential features without including the background details. Now, what is the meaning of this particular statement? And how it is so beneficial for us in the programming? Take for an example. Like suppose your mother has cooked some chicken biryani or paneer butter masala and you eat it and you love it. Now, when you are eating it, are you bothered that how that particular thing has been made? No, we generally never bother about those things. Similarly, a driver drives a car. Does he ever bother about that? What are the mechanics of the car and how the car is working, and basically what is the concept of physics or mechanics which has been included in it? Never. So basically, this is an advantage for us. Imagine if you try to ride a scooter, or if you try to learn riding a scooter or driving a scooter or a bike, then before you start driving it, you need to know each and every screws and nuts and bolts and machinery of the scooter. Then only you will be able to drive it. So do you think that it will be so simple? So what do? We actually forget about the basic inner details and we work on the superficial way. Same is the concept which is applied here. Data abstraction. Okay. The advantage of data abstraction is that any person who is working on any program which has been designed in OOPS need not be a programming or need not be a person who understands programming or need not be a programmer. He can work on it directly without understanding the underlying concepts of programming. Take another example of somebody who's working at the railway counter and reserving your tickets. Now, the person who is sitting at the counter, is he aware that how the program is working? No. He is simply told that, okay, you do one thing, you just click on this place and you get this work done. So this is abstraction. Now, coming to the next concept is encapsulation. Now, what is encapsulation? Encapsulation is basically wrapping up of data and functions in a single unit, which is generally known as class in OOPS. Now, what do I mean by this? Children, suppose if I tell you that, okay, these are 3 numbers, store them in your system. You create variables and you store these variables in your system. Now, if I tell you that, okay, these are marks and you add them and you divide by 3 and you will get the average. This gives you a meaningful information. Okay. But if I tell you that, okay, these are 3 numbers, add them, multiply them by 2, then divide by 3, and then again divide by 4, and then multiply by 7, and then add 2 to it. What information do you get? You don't get any information. It is not average and it is not any scientific value which we are coming across. It is just some random calculations. So this was one of the basic and earliest problems faced by programmers. When they were storing data, these data were basically numbers or some characters. Now, what kind of work could be done on those data? They did not have any method of specifying it. Okay, so different users use those data in different ways. Sometimes to get some meaningful information, sometimes to get some random information, which was not information at all. So, encapsulation was incorporated in object-oriented programming, where the data is stored, and along with the data, there are small programs which are stored, which basically specify that, okay, this kind of work can be done on this data. So that means data and the programs which are working on it are amalgamated or are tied up together. Okay, so it defines basically what kind of work can be done on that particular data. This is encapsulation, wrapping up of data and functions in a single unit. So you understand the meaning of data and what are functions? Functions are basically the small programs which work on that data. So they both are tied together. They both are joined together so that whenever those programs work, they work only on that set of data. Okay, and whenever that data is being worked upon, it will be worked upon only by that set of programs. Take another example. Like, for example, suppose there is a program for railway reservation and you store the data of different travelers in that program, and there is a program for like your report card calculation. Now, report card is another program. It has got different set of data. Railway reservation is another program. It has got different set of data. Now, can we interchange the data of railway reservation and this report card management system to work on each other, okay, directly or indirectly? No, it won't make any sense. So this is the advantage of encapsulation. So this was the second property of OOPS. First was data abstraction and second is encapsulation. Now, coming to inheritance, the third property, which is a very important property, and basically this is one property which has really proved to be a boon for all the programmers throughout the world, especially those who have been working on older systems like Fortran and all these other things. Okay, now what is inheritance? Now, the programmers, when they started developing programs, and especially the bigger applications, they found that number of things get repeated again and again in different parts of the same program. Okay, like take an example. Suppose we are working on railway reservation system and there is a part of program which does reservation. Okay, now this reservation is a general feature which has to be applied for like all the travelers which are going to travel, or all the travelers who are going to travel on railways or using railways. Now, when we look into this reservation category or the reservation program, it has to deal with number of things. Like for example, there are certain people who take certain kind of advantages while reservation, like people above 60 years of age, they get rebate in their ticket price. Children below 5 years of age. Okay, so am I going to create a separate reservation program for people who are above 60 years of age? And am I going to create a separate reservation program for general people? Am I going to create a separate reservation program for students who are less than 5 years of age, or basically that way, different categories of travelers? So here inheritance comes into the picture, or here inheritance becomes important. What we do is we create one program for reservation, and then we create a different class, okay, for suppose children, and a different class for people who are above 60 years of age. And then what do we do is we share the code between this class or this part of the program and that part of the program. So basically linking of two classes in such a way that their properties can be shared and the programming code can be shared without the need of rewriting is basically inheritance. Now, how inheritance is done? Inheritance is done by linking two classes in such a way that one class becomes father class and another class becomes son class. Now, as you proceed ahead in your programming or understanding Java, you are going to see that there are various access specifiers. What are these access specifiers? That again we are going to deal later on. Let us not break our head right now into it, but let us understand that there is a category of properties in a program which can be accessed directly from the father class to the son class. So I'll repeat myself once again for all those who have got confused. There are two classes. One, the programmer makes it as father class, or also known as super class, or also known as base class. Another is the son class, or the subclass, or the derived class. Protected properties of the father class will be getting transferred to the son class without the need of rewriting by the programmer. That means the programmer in the son class or in the subclass will be directly able to access the code which he has written in some other class. So this is inheritance. Okay, and it is one property which has really molded the way how programming is done. Otherwise, the program sizes used to become enormous. Now, it is something like this, that okay, there is one TV in your home and all the members in your house are accessing that TV. So when your father wants to see, he is using that TV. When your mother wants to see, she is also using the same TV. And when you want to see, you are also using the same TV. So here TV is the code, the program which you have written. It can be used by number of entities known as classes. Now, coming to the next topic, that is polymorphism. What is polymorphism? Polymorphism is basically a concept where a same thing, or where basically a same code, part of code, will behave differently under different aspects. Okay, like for another example, suppose if I ask you that, okay, or if your mother asks you that whom do you love more, your mom or your dad? Now what do? You see that if your mother is speaking to you or asking you this question, you say mother. And if you see that your father is asking this question, you say father. So basically, you are the same person who is behaving differently under different aspects. Your brain analyzes that, okay, right now, what should be my answer? And according to it, you give the answer. Okay, in most of the cases, you might be loving your mom and dad together equally. Okay, there is no way in which you can distinguish that, oh, I love my mother more or I love my father more. So what is happening here? You are the same person who is behaving differently under different circumstances. This is polymorphism. Okay, same is the case here. In object-oriented programming, we have got a concept where what we do is we design a piece of code, and then that same code will be behaving differently under different circumstances. What are those circumstances? How are they going to behave? And how are we going to do it? That is again going to come later on. Till then, you need to understand that, okay, polymorphism is an aspect where the same thing or same entity behaves differently under different circumstances. That is polymorphism. Apart from these, like 4 aspects of OOPS, what I had told you or mentioned just now, that was polymorphism, inheritance, and abstraction and encapsulation. There is one more which is not listed in most of the books, and that is modularity. What is modularity? Before C and C++ and Java, there used to be like huge programs to control satellites, maybe of 5 lakh lines or 10 lakh lines. Okay, now imagine, is it possible for one person to design a program which is spanning into 3 lakhs line and 4 lakhs lines? Not so. So C and C++ and Java, basically, they came up with the concept of modularity. Okay, now what is modularity? Modularity is handling different aspects of the program in different segments, where each segment is known as a module. Like, take another example. Imagine your video game. Your video game has got graphics, your video game has got counters to count your points, and your video game has also got sound. Your video game is also taking voice commands. Now, a separate group of developers will develop the graphics module. Another separate group of developers will develop the sound module. If both of these modules are developed by the same group, then naturally the program code is going to become bigger and they might get confused. So to make the things easier, what they have done is that they have divided the whole program into different modules or different segments dealing with different aspects of the program. This is modularity. Okay, so now with this we come to the end of chapter 2. The timing is already 17 minutes and 20 seconds. So number of advantages and disadvantages of OOPS are also there. The very first thing is reuse of code. So you can use the same code again and again, no need to rewrite. That I had told you in inheritance. Ease of comprehension, that is understanding of the programs becomes easier because different aspects are dealt differently, as I told you in modularity. And ease of fabrication and maintenance. So that means it is easy to write the programs because you are not taking everything together. You are separating the things in different parts and you are dealing with each part separately. So naturally the program becomes of a smaller size for you to concentrate upon. Like your mother does not cook everything together. When she is cooking sabji, and most probably at that time she'll put up dal or rice on the other burner of your stove or gas. So little bit what she does is she constricts the cooking process the same way. That is ease of fabrication and maintenance. Easy redesign and extension. So one of the biggest advantage of OOPS is that once the program is developed, it can be reused, it can be redeveloped again after a few years or after some time when a need of refabrication or remake, it has to be remade to add more possibilities into it. So children, we'll be closing here. This time I'll be coming I won't take so long to post my next video, so that we can move ahead. Until then, what you do is you just keep on following these videos, and side by side what you do is you read the chapter, whichever book you are following. Okay, we are following Sumita Arora in the school, so it doesn't matter whatever you are following. Read the chapters, read the concepts where these are given, so that you get a better understanding. And if you have a problem, please give a comment so that I can explain that thing again in the next video. Thank you. Good night. Sabah khair.